Hi, I'm Ruth. I'm a technical SEO analyst at DeepCrawl, where I help clients analyse their websites, identify technical SEO issues, and provide recommendations for improvement. And today I'm going to be talking about this problem, that SEOs are busy people. We often have lots of tasks that we have to complete and wear lots of different hats. But there is a solution in the form of automation, and more specifically, automation and data analysis using Python. So today I'm going to cover how I got started learning Python, how it can help with technical SEO, and share some practical examples of how it can be added to your SEO workflow. So my journey with Python started like this. I don't have a computer science degree or a data science background. I'm just a curious SEO who saw people talking about Python, was super intrigued and thought I'd see what I could do with it. And this is me now. I feel a lot more comfortable with the language and I'm really enjoying learning it and seeing what I can do with it. So just quickly, what is Python? So Python is an open source general purpose programming language. It's interpreted line by line and it's designed to be readable, so it's a great language to start learning. And because it's open source, it means there's a huge community of people that work on it, so there's always someone that can answer questions that you have or take your feedback. And here's just a quick example of how code gets written in the terminal and then results are generated directly beneath. So when I was researching Python, I found that some of the biggest brands in the world use it, and they either use it for powering their platforms or also for their data analysis. And this is companies such as NASA, Instagram, Uber, Spotify, and Google. Google have used Python since the beginning. Their first web crawler was actually built in Python, and it remains one of their official server-side languages. And YouTube also use it as it's fast enough for them to produce maintainable features, but with efficiency. And there's lots of ways that you can go about learning. So for me, the Code Academy computer science course was really beneficial. It was just a 20-week online course, and it had a mixture of theory and practical projects that you could undertake. And there was also a console and a terminal that you could play around with and test out what you've been learning. There's also Data Camp. This again has a wide range of skill tracks that you can try with interactive exercises and challenges and projects to put what you've been learning into practice. And there's also Solo Learn, which is actually a free mobile app. So you can learn Python on your mobile. Again, this has loads of practice questions and a code playground that you can play around with. And there's also some fun sites that can help you learn. This one is called Code Combat. And this is like a video game style where you basically use Python commands to control your character and move them around. So when it comes to using Python, you can run it in a number of different ways. So if you're on Mac or Linux, you can actually run it through your terminal. And if you're on Windows, you can run it in the command line. But there's also lots of cloud-based alternatives. So tools such as Google Colab or Jupyter Notebooks, and these just provide an easier experience for beginners to get started. You can test different elements line by line and see the results directly beneath. And you can also share what you're doing with others or look at other people's code and play around with it. So the main power of Python really is in the libraries. And this is because they enable for a number of additional add-ons such as data extraction and analysis, scientific computing, natural language processing, and even machine learning. And these are some of the useful libraries for SEO tasks. So I just wanted to quickly share 3 really useful libraries for SEO tasks. The first one is Pandas. So Pandas is a library that's designed for working with table data. It allows for a high level of data manipulation, and the key data structure is a data frame. And a data frame is essentially an Excel spreadsheet, but it's much faster and it's more efficient. It's not limited to Excel's row limits and byte limits, and it's not going to slow your computer down. So the best way to get started with Pandas is to take a simple CSV of your data. So this could be a crawl of your website, for example, and just upload it using Pandas into a data frame. And then from here you can perform loads of different data analysis tasks, mathematical functions, pivoting, and even data cleaning. The next library is called Requests, and this is a library which allows you to make HTTP requests in Python. It basically abstracts the complexities of making a request but puts it behind a really simple API. And you can use different request methods such as GET or POST to make requests. So a simple GET request for a URL, for example, this is going to print out the status code of the page. And then you could use this to make a simple decision-making function. So if the status code is 200, you know that it's a successful page. If it's a 404, you know the page has not been found. And you can also use different requests such as headers, and this is going to give you useful information, such as the content type of the request, a time limit on how long it took for it to cache. And you can also simulate a specific bot or user agent, such as Googlebot, to see how that views a certain page. And the final library is Beautiful Soup, and this is a library that allows you to pull data out of HTML and XML files. So it's often used for web scraping, and essentially it can perform a HTML document into a Python object, and then you can easily extract different parts of that HTML from the Python object. So for this, again, we can take a URL and the requests library to extract the title of the page. We can also extract other elements, such as all the href links that are found on that specific page. So how can Python help with technical SEO? And why should we care? So while having an understanding of the languages which power the websites we work on, such as HTML, CSS, and JavaScript, are super important, Python provides many automation opportunities for those low-level, time-consuming tasks. It also allows us to perform data extraction and analysis that can help us to solve complex problems. And this leads to efficiency and time saving, and essentially we're future-proofing our jobs as the world becomes more automated. So say, for example, you spend 5 hours a week using Excel. That's 20 hours a month, which adds up to over 200 hours a year. So just imagine what you could achieve if we spent this time on other important tasks that can't be automated. So the most common use case I've found for Python is working with large sets of data, which just simply isn't possible with Excel, because you start to open an Excel document that's just a little bit too large, and then it starts crashing your laptop, or you can't import the full data set, and then you find you're missing a lot of really important data, and you end up feeling a bit like this, and your laptop starts feeling a bit like this. This isn't to say that Excel is redundant. I still think it's really useful, but it's just not as useful as Pandas for working with really large data sets. And it's because of all of this that Python is growing in popularity within the SEO space, because it allows us to better understand the data that we're dealing with, and this allows us to make more data-driven decisions and provide concrete insights to our clients and stakeholders, but we can also have confidence in those recommendations and spend our time on other important things that we can't automate, that need a bit more of our attention. And there's lots of automation possibilities with Python. For example, you can check for 404s, you can perform internal link analysis, scrape websites, optimize images. And I just wanted to share some ready-made Python scripts that I started using when I first started learning Python that can help tackle common SEO issues. So the first issue is missing alt text. Obviously this is important for image search and for accessibility, but there is a solution with an image captioning tool that uses Pythia. So Pythia is a modular framework that's designed by Facebook, and you can run it through Google Colab, and essentially what it does is it looks at different parts of an image and weights the different parts in order to identify what it contains. So we use Google Colab to do this. We can run all of the steps automatically without needing to write any code ourselves. And this gives you a space where you can simply add your image URL. And from here, a caption this image button will appear, and this will basically generate a caption for your image, just like this. But it is important to remember that it is a machine, it is still learning, it's not going to be perfect all the time. For example, it thought this group of pandas was actually a herd of sheep, so it's always best to check the results that are generated. Another challenge is large image file sizes. These can obviously impact your site's performance and provide a negative user experience, but using an aptly named script called Optimize Images you can essentially use pure Python and the Pillow library, and this is going to optimize either a single image or a folder which contains multiple images. And I have an example here of an old blog that I used to have. This page had lots of images on it, and as you can see, the performance score wasn't that great, and one of the biggest recommendations was to optimize my images. So I took these images, I put them in a folder, and I ran it through this script. I then re-uploaded them to the site, and you can see that the score increased to 77, and the load time decreased by 7 seconds from those images. So obviously there's a lot more to site speed than just images, but they do have a big impact, and this script can help with that. And as you can see, there's no visual difference between the original and optimized image. It simply just reduces the file size. And Googlers have also been sharing Python code. So John Mueller actually shared this really interesting notebook about PageRank. And this allows you to essentially build your own site structure based on the number of categories and subcategories and then items that you have. It uses a default 0.85 damping factor to basically display a theoretical page rank when you're including breadcrumbs or not. And you can even visualize the link structure with the number of categories that you have set. And the best thing about all of these scripts is that you can run them all without needing to know any code yourself. So how do we go about adding Python to our workflow? So the best way to start adding it is to think about what you can automate, especially when it comes to performing really tedious tasks. To get started learning, the best way you can go about that is to actually play around with it, play around with data that you've got. Say, for example, you have a site crawl and you want to play around with the data. And that's how I've mostly learned everything about Python, is just from playing around with bits of data. Don't be afraid to break something. Play around with it, break it, try and fix it. That's our whole role as an SEO, is to find issues and fix it. So just take that same mentality with Python. So I just wanted to share some examples that I've been running recently that hopefully can inspire you and give you some ideas. So the first one involves segmenting your URLs. So basically this is just grouping pages depending on their URL structure. So we can use regex to break the site up into different segments, and then a small function that's going to loop through the list of URLs and add a new data frame which contains the rest of our crawl data and the segment for that URL, which looks just like this. So it gives each URL a category based on the URL structure. We can also do this without needing to manually create the segments, just by using the URL structure. So it's going to take the first folder that it finds, and again adds a new column to our data frame with the category that is set for that URL. Another example is work that I recently helped a client on, and this is where we wanted to review how relevant their redirects were after a migration, based on the category that the page was in before the migration and after the migration. So we took a pre and a post crawl and used a couple of really simple comparison operators to determine if the category matched or if the depth matched. And again, this displayed a data frame which contained each URL with the old category, the old depth, and the new category and the new depth, and it would give a true message if they matched or a false if they didn't match. And just like in Excel, we can pivot the data and get a count. So we got a count for all of the categories which matched and all of the depths which matched, for example. And you can then easily export this into a Google Sheets and share it with the client so they can see. Another project was some internal link analysis. So we wanted to identify which areas of the site were linked to the most. Did this impact performance? Were there sections of the site where we could improve the internal linking? So to do this, we segmented the data, as I mentioned before, to get the sections of the site, and then we could see which categories were getting the most links in, and again pivoting that data by the category and just getting in a data frame that gave you a count for the number of links going to those different categories. And you can also use mathematical functions to find out the average number of internal links to each section. And again, extracting it to Google Sheets and reporting it back to the clients in a really easy to view format. And then here's just an example of where I've added an average deep rank and level for each segment. So you can see if there's any correlation between those and the number of internal links that go in, for example. You could also do this with your Search Console data or analytics data. Also, we can perform log file analysis. So we can use the log file data that we collect from tools such as Logs.io and Splunk and identify which section of the site are crawled the most by Googlebot, and also see how that's changed over time as the site changes, again breaking it down by category and getting a total number of requests to each category. You can also use it to see percentages between non-indexable and indexable pages, and by status code to see if there's any potential crawl budget issues. And Python also allows for visualization of data, so you can make bar charts such as this, as well as line graphs like this to review hits over time and plot the requests. And then also we can do it here by looking at different categories, so we can see if there's any specific dips to certain categories as pages have changed over time. And with the Pandas library, there's also the ability to merge data frames together. So you can take, for example, different sources, such as a crawl source and a Google Analytics source, and get conversion data into that and combine that with your technical SEO stats that you're getting from a crawl. You could also do this with metrics from Google Search Console, such as your impressions, your clicks, your click-through rates, and combine this with crawl data such as internal link metrics. And again, we can group this by segments to gain a real view into the performance of each category and see if there's anywhere that we can improve. And there's also the Page Speed Insights API. So this was actually the first SEO-related Python script that I wrote. This allows you to measure key performance metrics at scale to save the time spent manually testing each URL using the Page Speed Insights. So this essentially involves uploading a CSV of URLs, taking each URL, looping it through the API, and saving it into one object, which you can then extract just specific metrics that you're interested in from. There's also lots of other metrics you can get from the Page Speed Insights API, such as finding layout shifting elements from a page, or a list of all the third-party blocking tags, and unused JavaScript and CSS files on each page. And another cool project I worked on recently was Core Web Vitals. So from this we extracted the Core Web Vital data from DeepCrawl and again segmented it to see which templates had the best and the worst performance for the Core Web Vitals. And this allowed us to see which areas needed to be prioritized when it came to optimizing the pages. So you can also do some really simple maths functions to get a percentage. So you can get a percentage of each segment that sits in each page. And again, here is just an example for LCP, turning that into percentages and getting the percentage of pages in each segment that sit in each bucket. And I like to turn this really quickly into a table and color code it so you can quickly see which areas you need to focus on. And I also recently played around with the Google Trends PyTrends library, and this allows you to collate Google Trends data at scale. So for example, you could see interest over time for a number of different keywords and suggestions of different terms to use. And you can also take this data and turn it into visualizations, such as this line graph, or pushing the data into Google Data Studio and creating customizable dashboards. But you can also have fun with Python. So for example, I created this bot that uses Python, Telegram, and the Random Dog API, and it sends a picture of a dog when you type in the word bop. And you can also use the Pygame library to create your own video game. So essentially, Python is becoming the future of technical SEO. And this is because it allows us to understand and solve problems faster. It also allows us to make more data-driven decisions and have confidence in the recommendations we're providing, as well as allowing us to spend time focusing on other important optimization activities, and improving user experience. But the truth is really, I have no idea what I'm doing. Like I said, I don't have a background in any of this. I've just enjoyed playing around with it and seeing how I can apply it to my day job. But I do have a few recommendations for anyone looking to get started. So first, speak to your developers. There's a high chance the developers you work with will have an understanding of Python. You can tell them what you're working on, see if there's any way that you can collaborate. You can also join online communities such as this Slack group where you can ask questions, get advice, get tips, or get inspiration. And also take part in the 100 Days of Code challenge just to keep practicing and build up a habit. But most importantly, have fun with it. Don't put too much pressure on yourself to learn at the speed everyone else does. Just learn at your own pace. There's so many great people in the industry doing amazing things with Python who inspire me every day. So I would definitely recommend giving these people a follow. And also I just really quickly wanted to shout out the DeepCrawl professional services team. Since I've been working with them, I've learned so much. They all do such amazing stuff, and we're looking forward to sharing some of the cool stuff soon. So just a few takeaways. Python can help technical SEOs increase their efficiency by automating repetitive and time-consuming tasks. Being able to better understand the data that we're dealing with will allow us to make better decisions and have more confidence in our recommendations. And anyone can learn Python, you just need to have a little bit of fun, put some commitment to it, and see what you can create. And just a really quick reminder, you don't need to learn Python or any other language in order to be a good SEO, but if you feel like giving it a go, just see what you can do with it. And just some useful resources for anyone that's looking to get started. Thank you.